Welcome, everyone. So tonight, our main module objectives is to be able to describe how Windows work, how it's structured, and where it holds the data for the users. I want you to be able to identify the Windows tools that will be used for troubleshooting, and then also the best practices when you're dealing with Windows-related problems. So first things first, we're going to look at what are the shell and the kernel, and how are those two related? And I guess the best way to view this or to understand it is to think about how Windows is an operating system, you know, and it's basically split into two components. So one of the components is the shell, and the other is the kernel. So we're really viewing our operating systems, the Windows machine, as a with a bird's eye view. We're kind of stepping back. It is a little abstract. Um, so the shell is the part that we interact with, like the File Explorer or the desktop. Those are all the things that operate in the user mode, as you can see right here. The kernel operates at a deeper level. So it handles the hardware interactions through the main two components, and that's the HAL, the hardware abstraction layer, and also through the executive services. And that's the interface or a group of services that operate the kernel mode between the user mode, subsystems, and the hub. So in simpler terms, the shell is user focused while the kernel is hardware focused. Okay. And together, you have yourselves the operating system. Okay. So that's kind of how it's divided. And the kernel, so these two, if we had like a Venn diagram or some kind of hierarchy of organizational charts, these two functions or components would be under the kernel part, and the shell is more the hardware part. So now let's take a look at the useful settings and the control applets is what they call them. So Windows provides various applets and settings to customize and to troubleshoot the system, all right? And then these tools they're basically managing the system operations, right? So they all have specific jobs. So for example, the control panel and the settings allow you to manage accounts and devices. Um, we can look at that. Like if I were to pull up, let's see, my own let's see, control panel or even settings. I have my settings here. So under my settings, I could find my control panel probably just by searching control panel, and then it will come up. So if I do control panel, that's going to take me to my control panel. And here I'm able to modify my users and programs, hardware, software, and whatnot. I should be able to find a lot of things in here. I can customize and personalize things. The clock. The clock on the machine is not as reliable as the internet clock is, from what I'm understanding. And I mean, of course, every system varies, but the battery that keeps track of the time when your system is unplugged, that thing can go bad. It could go slow, and the next thing you know, your time is just not that calibrated. So just watch out for that. How's it going, Charlie? See you in there in the chat.
Doing well.
All right. So yeah, we're just gonna go through everything here and and keep it moving.
It's almost a personal class, it feels like.
Yeah. Well, this is a nice kind of a way to look at everything. Our applications are part of the shell. The shell will hold all of those things, and then you have the kernel is now dealing with some of the other services, right? Um, and then there's also the configuration data and those files, right? And obviously Windows, Windows is very picky about their software, and so a lot of things you're not even supposed to have access to. I think it's part of the user agreement as well. And so a lot of things are going to be hidden and just locked down. But I think it is possible to access them, but you're not supposed to mess around with it at all. Um, so how much autonomy do we really have on our own machines when we have the Windows operating system? Like if we're administrator in our own personal machine, we should be the god of that system, so to speak. And I don't know, it's kind of it could potentially create a debate on whether or not we really do have all the power over our machines in a Windows system. Um, but of course, there's a good reason why they do the way they do things. There is a good reason why. Um, so yeah, yeah, no. So again, like I said, the control panel will modify the settings and all of these things. So that's kind of where you can find different things at. Let's look at the next structure. So this is the directory structure, right? So the profile namespaces, the program files. So when a user signs in, Windows creates that profile and it gives them their folder, their own settings, and it's all a part of a file called the ntuser.dat file. It's a hidden file stored under the user. And we do, as admins, we do have access to all the hidden files and things like that in the settings. Um, there's also the program files, right? So to actually run the programs where programs are installed, some of their files are in either program files or sometimes they're in something called program files with a x86 next to it, or even, uh, well, yeah, depending on if it's a 64-bit or 32-bit. So, but understanding the structure is actually pretty crucial, because when you're trying to troubleshoot user-specific issues, um, you will have to be able to navigate the system settings, and depending on the type of program you have or applications, you have to be able to find the application files and settings and things of this sort. And the other piece that we're talking about were the directory structures is the Windows data. Okay. So Windows stores the configuration of system data in a specific location. They're like a registry, and it's text-based, and they also have the initialization files in there as well. But some of the key files, as you can see right here, are the systems32 config directory. You have um, the backup registry. So that's going to be under config, but then it's reg back. And then you have the fonts. And then some of the temporary files are going to be in here. So these are some of the important locations for the registry and the other Windows data files. And notice in a Windows system, where we have the backslash, whereas in the Linux-based system, it goes forward. So it's just the directory structures are different. All right, let's keep going. So here it says, how are Windows, how does Windows manages the applications, right? And these are the processes. So a process, you know, is to me the way I visualize them are like they're like cells in the human body. And the threads are okay. Let's not. I don't think we need an analogy for the word process, the processes. But a process is a program that's running under the authority of the shell, together with the system resources assigned to it. So these are the guys that carry out the tasks. Um, so Windows basically treats each running program as a process. So any program that's running, it's a process, and the process may include one or more threads. So threads are the individual tasks the process requests, like printing a file, for example, right? So understanding the processes and the threads is pretty critical as well when it comes to identifying resourceful, intensive type of applications. So that's kind of what's happening there. Let's look at where we could see those tasks. Again, the task manager shows the tasks. So if I pull up the task manager, um, I have 7 apps running, but now there are several background processes running as well. And it just goes on and on, quite a lot, quite a lot. So to keep Windows afloat, and some of these programs I may be using or I may not be using. Some of them I'm probably using indirectly. Sometimes it's just too confusing to know what's what. There are some things that may look a little shady. Um, and then you have, if you keep going down, it's the Windows processes. So that's different from the ones that's running in my background. So we have the apps that I've created and opened, and then there's the background processes, and then further down, we have the window processes, and these are, I have the power to right click on them, go to the details, look them up, find out what are they doing, how much are they space are they taking up, how much memory do they take up, and the amount of power that some of these things are using. Um, so it's pretty interesting to dial into what what your processes are doing and the threads that they're taking up. So if you have a processor that has a lot of threads, and your machine is going to be more of a workhorse, right? You'll be able to multitask and do all of these things and have all these programs running simultaneously. Like if you are into gaming and streaming, and as you're streaming, you're recording and you have microphones and the whole works. You're gonna need a lot of power in that machine. So right now, Zoom is taking a lot of my power to keep Zoom running. I know it's live video, it's pretty quick as well. Maybe if I were to take my camera off, it might save a little bit of bandwidth and power and things of that sort, but maybe not. I can go to performance and really check the bandwidth. I could look at app history startup. And the startup is the one where I go to quite a lot. Sometimes after updates, they go back to their default status. So you got to watch out for that. A lot of Programs will try to start in the beginning and it just slows your machine. And so it is possible to just simply right click on that and just either enable it or disable it so that it does not start up every time you cut on your machine. Because if you notice, the impact of some of these are extremely high. And you talk about, having a slow machine, that would do it, especially Microsoft Teams. You know, they want the big one to open, and you could just go there on the website. You don't even have to have that. So that's that one. Slide 7 is going to be a quick knowledge check. Okay, so we're gonna go through this and then look at that solution. So here's our a scenario that kind of just test your understanding. So you're trying to install basically a 32-bit app on a Windows 64-bit machine. So where do you look for the program files, right? And remember, so I'll just read it real quick. It says you're having difficulty uninstalling freeware a user accidentally installed while surfing the web. You look online and see the software is designed to work in an x86-based version of Windows. In which folder should you expect to find the program files for the software?
Is
And
it B?
so you're going to go with program files dash 86. Yeah, remember now, if it was a 32-bit, um, it would be in just program files, but we're dealing with an x86. So yes, B should be it. Well, wait, hold on. They're saying when we go to the answer, though, they're saying that it actually depends on the version. It actually depends on the version of the Windows installed. Um, an x86 based app is a 32-bit app, but if Windows is a 32-bit, the app is installed in the program files folder. If Windows is a 64-bit, the app is installed in the C program files folder. So I guess we we weren't sure whether or not the version of Windows, which version it was, because they never really specified. And I think that actually brings up another point. Like, what is x86? Does anybody have any familiarity with that term?
Does ARM base run x86? Sorry, do ARM processors run it? I'm eating dinner right now. I really apologize.
Yeah, so well, first of all, x86 basically means that it is a 32-bit architecture. And that's just I don't know the history of the 86, the actual number, but when you see x64, um, then that lets us know that it's based with a 64-bit architect. Um, so that term refers to the the type of version of Windows that the system is running, the operating system is running under. So the amount of bits that the operating system is running under. Um, yeah, this question is actually a little confusing though. So again, the explanation, let's just go over this one more time. An x86 based app is a 32-bit app, but if Windows is 32-bit, the app is installed in program folder. If Windows is 64-bit, the app is installed in the C program files x86 folder. Okay, interesting. All right, let's move on. Survey of Windows tools and techniques for problems for troubleshooting. So it says here, Windows provides many useful tools and techniques for managing troubleshooting applications. Um, and then they're saying, you could look at the table in the book for many of those resources. So, and I mean, we could pull up the book at any time. Hopefully you guys all downloaded it. Um, let me see if I can find it real quickly. I don't have to, let's see here. 14.1 here. Yeah, we talked about this. Figure 14.1 inside the operating system. Yeah. So we have the hardware, we have the kernel, the shell, the config files, and the whole of the machine, the operating system, and the hardware. So yeah, um, that all makes good sense. Okay, so we're going to look at this real quick. The event viewers to look for clues. So the event viewer logs can give clues about the hardware or any type of network failure. Because remember now, we're trying to problem solve, certain issues, and sometimes we just don't know what's wrong. We might have, depending on what crashed it or what corrupted the system, we probably have some ideas, but we still need to check everything out. So um, a good place to check would be the event viewers, basically. So the most useful logs will be the applications, the system, and the administrative events logs, because those almost always point to the root of the problem. All right, and now let's look at the resource monitor. So the resource monitor provides the real-time data on how the resources like the CPU and the memory and the disk are being used. So, for example, if a hard drive shows more than 80% disk time on a high disk queue length, it indicates a bottleneck slowing of down performance. Okay. All right, let's keep going. So and this is where we start to get a little bit into, hey, what if I want more performance? Like what if that's my issue? My machine is um just not performing. Um, so here the performance monitor is that tool that, and we just saw a picture of it. Um, but here it's a diagnostic tool that will track resource usage in real time, and it can actually save the logs for later analysis. So, and the tool is also pretty useful for identifying patterns of resource and strain over time. So, such as like the CPU, the memory, the disk usage, it spikes and all that. A practical example would be monitoring disk performance. And so, as you can see, if the percent of disk time is more than 80%, that could create a huge problem for the threads of the processes actually carrying out their duties, and you know it could potentially happen. So we have to figure out how do we handle those kind of things. It's not always about just deleting everything and reinstalling it all. Yeah. So let's look at that task manager again. Now they're going to talk a little bit about that task manager here. So it basically shows what's happening now. So you can do a Control Alt Delete. Um, you will get this. I don't know. Do we have any brave souls that wouldn't mind sharing their screen, maybe, if you wanted to? Um, and if you decide to, actually, I just activated multiple participants can share their screen if they choose to. Um, does anybody want to maybe show your task manager? And maybe even your startup, maybe have you fiddled around with any of those um, startup, disabling things like I do all the time? It's one of the most commonly used things for troubleshooting because sometimes you could just right click on something and just end the task. That's called killing the process. Because when you're in the command line, you can control the you can do everything you can do. Everything can be done in the command line. You just have to know the commands. But you essentially have all the power as you would on a Windows machine. So anyway, when you pull up the processes on the command line, the command is PS. If you type PS, that will pull up all the processes running. But of course, the command could get more intricate depending on the options of that command. But to kill a process, you would literally type kill, and the process will just end immediately. And so that kind of reminds me of the task manager. Like if something hangs and you just get like a blank screen and it just hangs and the program like just doesn't go anywhere and it doesn't even respond to your mouse, you could probably go to the task manager and you might be able to shut it out that way, just by right clicking on something and hitting in task or going into the details of something and getting it done that way. Spotify was draining something, that makes you wonder, right? Was your spidey senses kind of tingling? Like, wait a minute, Spotify, what in the world? I just uh why so much resource? What are they doing to me? Are they, yeah, I don't know. I don't want to turn into a conspiracy. Oh, that, that's uh that's gonna be a good one. Yeah. Um, what about those tab overviews, right? So the different tabs, we looked at a couple, the startup tab, the user tab, the service tab. It would be a good idea to be very familiar with these in your task manager. So when you do pull up your task manager, you kind of should know what the tabs are all about. Like the processing tab will kind of show, like by default, all the running processes. The performance tab will show the live graphs of the CPU. The startup tab shows all the programs that want to start up at launch. And sometimes they get in that tab by how you installed that software. It, at some point when you installed the software, probably by default, it said um, allow the program to start up during startup or something. And then there's also the user tab and then the service tab. And those just show how the user specific activity and the background services and stuff like that. All right, let's move on to the services console. So the service console, it it's basically accessible by running the command services.msc, and that will permanently adjust when services run in the background to support Windows and applications. Now, this probably could have the potential to to speed up your machine. Um, if a service fails to start, you can also check the properties there as well and kind of ensure it's set to either automatic or manual. Um, a common troubleshooting tip is if a service continues to fail and then reinstalling the related application or updating it, its dependencies may actually resolve the issue. All right, let's move on to the system file checker. So there is something called the system file checker, and this is going to be used to verify the Windows system files. Okay. It's pretty incredible. It can address system instability and also crashes. Some files could be damaged, right? Just whether by content or they have something written in them. You might want to also use this tool like after an update fails or if a critical system processes are kind of not behaving right. So you could just do a scan now at SFC forward// scan now, and then it will just uh, start to scan your system there. All right, let's look at some system configs, and I think this is probably where you're going to want to go to activate the hypervisor. If you have it, it depends on the version of your operating system. If you have the Pro, like some of you do, you're going to have to go into either this area or another one. Um, but it definitely allows you to do some troubleshooting after the startup. The service tab will actually let you disable certain non-essential services. So that can also help eliminate problems as you're trying to solve things. The tool tab is there, and that's just going to provide some easy access to other troubleshooting utilities. So um, the task manager and also the event viewer, that you can find those in there. Now, where would you go to actually pull these things up? The truth is you probably will just search for it. Is the way it's probably done. You would type in maybe system config, hit it, and then boom. And then services. Okay. It's just there's an awful lot. I do have the hypervisor is I don't know why it's running. Okay, maybe it needs it for something. Um, startup. Okay, so we can get into that task management tools. So, all right, system restart. So this can actually roll back the system settings and the configuration to a previous state. So this can actually help resolve issues caused by recent changes. But it's also important to note that you have to already have restore points that already need to be existed. And It also won't remove any viruses or worms if that is your issue. Um, but it could help. I mean, it's not the fix that will um, it won't fix like if the registry is completely like corrupted, but you can think of it as like a time machine for your system. It's useful, but with limitations. So system restore, let's look at that other slide. Um, this is what it would look like, right? So maybe, hey, if you like your machine where it is, maybe you should do a um, restore point so that you may be able to bring it back to this state. This is actually pretty valuable when you're talking about virtual machines. Virtual machines, you can do this quite a lot. I mean, you can just freeze the machine, you can stop it in its tracks and pause it and shut it down and come back to it when you pop it back up again, and it's back to its original state. Um, that's pretty nice about that. Yeah, you know what? I don't think I've ever done one for my own. Let me see if I can find system restore. Well, here I could probably get to system restore by clicking on here. So you can undo system changes by reverting your computer to a previous restore point. Well, yeah, I don't want to do that, but I probably would want to kind of freeze everything so that I will have the capable of doing this. Okay, well, for personal machines, we don't really do it all that much. This is more for like when you're, controlling, things a little bit more high stakes. Well, actually, your personal machine is actually pretty valuable, though. It should be done. All right. So what's up with this one now? This is where I've had to mess around with the registry before. This is where, I was troubleshooting and got guided toward this and kind of just followed whatever I saw at the time, and it worked. The registry editor, it allows you to manually change to basically make changes to the Windows registry. And it's kind of like a hierarchy of a database. So it's very organized in like a tree-like structure. Um, the five key hives, they call them hives. It's the SAM, the security software system, and also the default. So they have the H key, local machine, classic root, classic user. Now it says always back up the registry before making changes. The mistakes here can severely impact your system. So here are the five keys. So you kind of have to know which one to go to find what it is you might need to do. Here is what they're saying, what we just said. Make sure things are backed up. Um, you can even restore the individual keys there. So this is kind of how the structure looks. I mean, it just goes deeper and deeper and deeper. And you finally find whatever it is you're trying to find and make changes to it, and then boom, everything is fixed. Okay. The registry is pretty important. All right. right, so here are the steps to solve any computer problem in 6 steps. But each step could take a long time to do. So identify the problem, uh, and then basically develop your theory. Okay. Test your theory, fix the problem, resolve the problem, you know, verify that it's been done. And then 6 is to implement preventative measures. All right. Document whatever you've done. This will ensure, you're addressing things in a very methodical manner, and you also reduce the likelihood of the problem happening again in the future. A lot of times we don't think prophylactically, but sometimes we should take preventative measures from things happening instead of always being the firefighter or putting out the smoke and whatnot. Okay, now services not starting, right? What happens when this happens? Um, so when services fail to start, you got to check if they're configured to start automatically, and also verify any related dependencies. That's usually how it's done. So you'll use the service console or the task manager, and then just check their current state and start the service manually if you need to. Um, if it's still kind of not doing it or not working or still kind of unresponsive, reinstalling the application or actually verifying that the system updates just might be necessary. Okay. All right. So we have the USB controller. The USB port, it just might fail or become unreliable because their drivers are corrupted, or because the power options are just not configured properly. Those are usually the problems there. The device manager is kind of your go-to tool for resolving these problems, and it will update and disable and reinstall the drivers as needed. So check the power options. That's a lot of options when you check that power. And that will also kind of ensure that the USB selective suspend is disabled. And that will actually prevent the device from becoming unresponsive. So the selective suspend, when that's disabled, then that could help. Okay, time drift. It's also called clock drift. It happens when the Windows system does not report the accurate time. I had this happen to me. Luckily, I was able to just sync my time with the internet and have the internet manages it. But there are batteries inside the computer, um, to keep track of the time when it's not plugged in. But yeah, I mean, having a time problem on your machine could potentially be a huge problem. There are applications that are time sensitive, right? Um, for domain connected systems, the Windows Time Service will will use what's called the network time protocol, and that will maintain the accuracy. So you just got to ensure that the service's startup type is to automatic, is set to automatic to avoid those disruptions. So here, as you can see, you'd pull up Windows Times properties. You would go to the startup type, hit automatic, and it will set that time. Oh, low memory. Um, when you get that warning, basically that indicates that resource exhaustion is happening, and it could be an issue. Like I'm facing this problem actually right now with my C drive, right? I'm down to under 200 gigs, which is not a whole lot anymore. Um, so here, what they're saying is to check the task manager inside the process tab and all of that, and check the memory usage and verify the physical and virtual memory settings, and then updating the chipset drivers as well. Updating the RAM are long-term solutions, but it's not out of the question. You always want to upgrade stuff and maintain things. Okay, I do have a machine that's sluggish. uh, so here they're giving you the steps on what you would do to kind of problem solve this. Basically, you know, verify the updates and this antivirus systems, remove any unnecessary, startup programs, literally remove them. Um, Not only disable, optimize the hard drive. Also check that task scheduler. That can be reviewed for unnecessary scheduled tasks that's slowing down the system as well. So, all right, we're getting there. Let's keep going. Here are some general steps you can follow to observe the system and solve a problem here. So you'll kind of look at the event viewer, update the windows, and then you want to, suspect these different things here. Right. So the general steps you can follow to observe the system and to solve a problem are here. Suspect the corrupted devices and drivers and all of that good stuff. All right. If all else fails, just uninstall and reinstall the application. But sometimes running the program as an admin or verifying digital signatures can also resolve compatibility issues. Okay, we're going to look at, let's see, I think there's another knowledge check coming up as well after this. Let's check that. Yeah, so we looked at this. If something crashes, consider um, end a hung application, search the web on error messages, consider data corruption, check the application systems, repair or update, and then uninstall and reinstall. Okay, update, run installation program as the admin, verify the signature and all of that. So how would you run something as an admin? You would right click on it, which remember, running something as admin, if you are the admin of your machine, you have every right to do everything as admin, right? I mean, you can view, you can read, and you can modify, which is write and save things to the system, to the buffer. Okay. Yeah, there's some errors here, digital signatures, like yeah. All right, so we do have a knowledge check this time. Um, when trying to improve performance of a slow system, you notice in the task manager that the superfetch service is using a high percentage of CPU time. What is your best next step? A, B, C, or D? Let's see. Anybody want to put an answer in that chat? Let's see. What do we got? What should we do here? We're trying to improve performance. Should we disable superfetch? Should we update the Windows to improve superfetch performance? Superfetch is essentially a Windows process that should not be disabled. Move on to other solutions to improve performance. Or ask the user if they use superfetch service, and if they don't, uninstall it. D. Wait, did somebody say D? Who's thinking D there? Ask the user if they actually use it, and if they don't, uninstall it. I mean, that would be very courteous. I don't see why that wouldn't potentially work. But in terms of the best next step, this is where this is where they start to get us, right? They're both good, but if we had to make a decision on what's better, I think, well, as admin, do we not ask users their opinion? Superfest could be a service where they depend on it, and if we disable it and they don't know, they could become a disgruntled employee or something, right? What is your best next step? So they did say A, and they're going to explain here. This was a tough one, but you can just right click on it and disable it, and that should actually help improve your performance. I mean, it's taken a high percentage of CPU time. So this Windows service cannot be uninstalled. It is supposed to improve performance, but can actually degrade performance on some systems. Wow. The thing that's supposed to improve it is the thing that's pulling it down. It's pretty sad. If it is hogging CPU time, it should be disabled. This question includes information not in the module and is designed to help you learn to use the web to research a problem. A good search string is, what is Windows Superfetch? Okay. Yeah, the knowledge check, these two knowledge checks that we had tonight were so tricky. But we need to start to do more of these types of questions. And so I'm going to be bringing in more questions like these. Um, so the lesson is pretty much ended. We should be able to kind of describe the way the window is working, the structure, where the data for the users are, where the settings for the program files are, identify the tools and applications, and also best practices to troubleshoot Windows related problems that have happened in the past. Okay. All right. That was a lot that time. We did cover quite a lot. Let's take a peek at where we are now. Let's go back to, I'll just share out one more time. So 14 and 15 over the next week, and we could look at 15 and 16 next week. These were a little smaller. Troubleshooting Windows after troubleshooting Windows startup. So it was after startup, and now it's startup. So troubleshooting is a big piece of this curriculum. So there are actually index cards, or to talk about hard boot, cold boot. Okay, that is you know, that could actually jack up things, ripping out the cord and whatnot. Sometimes it has to go through a specific process, when it's powering down. And if it's not able to finish that process, then it could be a problem. Booting. It is the process of starting up a computer and loading an operating system. Soft boot. All right.